Welcome everyone. Good morning, good afternoon, good evening, depending on where are you located. For those who don't know me, I'm Sandra Villacorta, the chair of the IUGS Commission on Geoscience Education. This is a webinar that we are organizing in the framework of our subcommission on education outreach and policy. I'm very glad to introduce you to Paul. Paul clearly, which is a lead voice on artificial intelligence applied in geoscience research. So I will read the resume that Paul sent to us. Paul is a geologist, a computer and data scientist with over 30 years of experience in the natural resource sector. He has led major projects across multinational companies and technology startups, and he's two-time recipient of the UK's highest business award for enterprise innovation. Paul also is a visiting professor of information science and technology at the Robert Gordon University in Scotland, and he is the chair of the AI Ethics Task Group of the IUGS Commission on Geoethics. I personally admire Paul's work because he is very good at translating all this complex information in something that we can share with the public in a practical way. So, Paul, the floor is yours. Thank you for being here again, and let's start.
Thank you, Sandra, very much. Nice to see everyone today, and thank you for inviting me. I'll just share my screen. Is that all good?
Yes, perfect.
Great. Well, delighted to be here and be invited. So I'm going to talk about large language models and their role in geoscience education as opportunities and challenges. Hopefully to spark some ideas and some questions. It's going to be a bit of a journey of all sorts of things. So hopefully there's something in there for everybody that will be of interest. Oh, bit of background noise. Was that a question? Okay. Yeah, talk a little bit about the background, LLMs, education, general purpose language models, and also retrieval augmented generation, and then talk about turning text into numbers. A lot of people have asked over the years, how do we do that? So give some examples, and then get into some of the detail of how we might use language models in the geosciences, or they are being used, and then go on to ethics and AI literacy. So in terms of the background, we just sort of go into it. The end of 2022, we had generative AI in the form of ChatGPT emerge, which became the fastest adopted consumer app in human history. We have around 1/8 of the world's online population that are using generative AI regularly. So most people are using it outside work, probably more so than inside. Some survey results in the UK, around 70% of university students using generative AI regularly. These are the sort of top 3 uses: ask questions, explain concepts, identify sources for a topic, and then also suggest improvements to a piece of work they've written and to support arguments. More globally, things are split really. Around 48% of people feel the benefits of AI outweigh the negatives, although there's general consensus around concerns for privacy, for security, the quality of the outputs we see, and fake information, and of course some very good research around how we anthropomorphize outputs, sort of treating them a little human-like, which of course can in itself raise risks. And then all the wider concerns on how AI can make people less intelligent as we cognitively offload some of our tasks, impact vulnerable people, and also bad actors use it to manipulate our attitudes. So really touching on huge social science implications. Interesting finding from that survey from Smith that around half of students believe that the university's AI policies set out the boundaries for acceptable AI usage, but have not actively, or around half of students felt they've not taught them the skills to use AI well and how to avoid its pitfalls, which presents an opportunity. And of course, when we talk about AI, we talk about narrow, weak AI, not some artificial general intelligence aspect. And predominantly, of course, we're talking about machine learning with also some knowledge engineering and rules. There are different types of large language models. There are closed, which we use online. So ChatGPT would be an example, Claude. They're free to use in their basic form, and then there's also subscription options. And then there are open models. Critical to know that they're not open source, so they're just free to use, but also downloadable. So you can download a model to your own computer. For example, Llama 3.1 8 billion parameter. If it's quantized, where you're reducing the floating point of the weights, you can run that on a 16 gigabyte RAM laptop with just a CPU. And there are some models you can even run on your smartphone. So there are models that you can download as well as ones that we can use online. But really no large language models are open source, or very few. Olmo is one of them, Olmo 2 from Allen AI, where they've released the training data, the methods, everything, so you can reproduce it. But in general, the proprietaries, whether those are commercial companies, non-profits, or governments, they haven't released training data, all the methods, and various other things. So it's not open science, not open source, and that's something to bear in mind, particularly around reproducibility, which is obviously a core element of science. So be very careful when people talk about open science in terms of language models, which they have done in the geosciences. And then for data security and privacy, we've got to be careful uploading sensitive information, of course, to these models that could be used without our consent or as part of the training data, and check the terms and conditions to ensure that they're satisfactory to you, and if they're not, then don't use the platform at all. So very much, it's a conscious choice to use these tools. And then in terms of this is back in October. Of course, it changes quite often. This is a ranked um, table of language models. So you can see it quite dominated by OpenAI in terms of the performance. And then the open models you see, or open weight models are down on the 3, not open source, but open weight. And again with OpenAI and some others. So in terms of general purpose large language models and also geology specific, it's useful to bear in mind that a lot of the general purpose language models we use, because they're trained on the internet, they already have quite significant amounts of geological terminology knowledge embedded within them, because geological surveys, academia, non-profit, have released a lot of geological information. So there's quite reasonable terminology understanding. Where people have tried to train models, such as Bloomberg trained Bloomberg GPT for finance, that was quickly outperformed by general purpose models like GPT-4 for finance. So you've got to be careful around technical debt. Perhaps a rule of thumb is if you're trying to build a model for content that you don't find on the internet, for example, around medical records, you don't find medical records on the internet. That would be a good case to maybe tune a model. But if you're going to use public content that's already on the internet, you'll be careful you don't actually produce something that becomes out of date quite quickly. And there's been some work looking at today's geology specific fine-tuned language models, and they actually perform worse than some of the state-of-the-art general purpose language models from a range of factors for going out of date and catastrophic forgetting. So one of the key things to think about language models, when they first came out with ChatGPT, when you got an answer, you didn't know where it came from because it's coming from inside the model. And of course, as scientists, you're not going to trust that. It's just in the way that if you read a literature review and there was no references to anything, you wouldn't trust it. So there's a technique called retrieval augmented generation, whereby the actual information comes from outside the large language model. That is retrieved in sort of chunks, and then the language model then interprets that output, which means that the assertions or summaries or reports that are generated can all be linked back to the provenance of the actual reports and paragraphs of where that information came from. So it's more ethical, it's transparent, and it's more likely to be trusted. It doesn't eliminate the errors or possibility for what's called hallucinations, but is what most organizations are deploying. And there's some evidence that using those techniques with authoritative geoscience content, good prompting, can store around 75% on PhD level type questions. That's not to say that there's not room for local models. Um, if you want total privacy, you of course can run a local language model on your own infrastructure. If you have a very narrow task, there's no point in using a sledgehammer to crack a nut. It may be that the small model that you have is adequate, is more environmentally friendly, and more optimal to use. And then the example there on the right is Google Notebook. So this is free to use. This is a hosted language model. You can see there on the left, I've uploaded my geoscience documents around the Sumatra area. I'm asking questions, and then all of the answers and summaries coming back. I can link to find out the source document, trace it back to the original material, so we have that transparency. So although it's using the Google Gemini model, all of the answers are predominantly coming grounded in my own information. Bit of a wordy slide, but in terms of environmental footprint, there's been quite a lot of discussions around language models. There's a great paper from JEGM this year with also a dashboard where you can go and choose different language models and actually see the energy usage, water usage, and so on. Model size is a big factor. The bigger the model, the more energy hungry it is, and also the infrastructure it's running on. Those two elements are quite significant in terms of the watt hours that are used for the model. So inference was reported to be around 90% of a model's life cycle. So yes, it takes a lot of energy to train a model, but actually it's then the usage of that model throughout its life cycle that generates most of the footprint. For a short query, so you're asking a very simple question of a language model, it's about 0.42 watt hours. And just as a comparison, Google query is about 0.3. So if you actually got to information quicker through a single query in say ChatGPT compared to maybe a few queries in Google, it might actually be more energy efficient. Median queries, you're looking at 1,000 word input, 1,000 word output. You're getting up now towards 4.1 or so watt hours. And just some analogies, using a laptop for 5 minutes equates to about 2.5 to 7 watt hours. Charging a smartphone, really anywhere from say 5 to 20. So again, averages, if you were using ChatGPT, around 8 queries a day, mixture of medium and sort of short queries, is probably equivalent to charging your smartphone for about 1 or 2 charges. So some of the bits of data there, one of the big changes is if you start to upload documents. So it's something that you can't do in Google, of course, but if you're uploading 10, 15-page documents constantly, or asking these language models to generate it, that's when you really start to burn those CPUs, more computational, complex. So I think by having some education on the use, we certainly don't want to stifle people use it, but hold the proprietors accountable. But we don't want to stop experimentation. But maybe through education, we can mitigate, perhaps uninformed use of language models, unnecessary or excessive, which could be more responsible in terms of environmental footprint. I'm not going to go into the details too much on these, but just to let people know that there are some UNESCO AI competency frameworks for both students and teachers of using AI, really based around sort of human-centric, including ethics and the applications and system design. So these could be useful resources if people are thinking of developing some courses. I'm going to talk about Bloom's taxonomy. It goes back to the sort of 1950s, quite a simple sort of model of how we generate learning outcomes. So you can think of the different tasks that you might want to teach and to assess around sort of remembering facts, almost direct parallel there to information retrieval. The use of search engines and Google, moving up to sort of understanding how we can classify, translate information, come up with examples, and then what's sometimes called higher order tasks around analyzing, comparing, and contrasting information, evaluating, judging it, and then creating original work. Of course, it's a very simple model, but quite interesting. Um, I mean, reality thinking happens at all levels almost simultaneously, rather than thinking that this is like a hierarchy as such. And of course, knowledge is socially constructed for a large part. But I think some key messages here, individual growth comes from the struggle to make sense of information. And so that's a useful thing to bear in mind when we use AI. Interesting study here from Oregon State University of mapping where generative AI can supplement learning throughout that Bloom's taxonomy. So we've got the same colors, the same levels, the sort of distinctive, what humans bring, our creativity, our use of ethics, imagination, and then on the right-hand side where Gen AI can help us through processing large amounts of text, statistical pattern recognition, and some nice examples of where this sort of co-creation, human AI teaming, with very much the geoscientist in charge, but then using these tools just in the same way that calculators helped us in mathematics, but help us on these learning and reducing uncertainty exercises. And I think that the key element we talk about understanding, of course, language models. They in some respects are next token prediction, but they do have some emergence. If you put a large amount of text together, you are going to find certain connections that can be useful, which are not present in any single document. But of course, it is statistical, and to some extent, there's no understanding of some of the text that's been produced. So they can support our independent learning, and plenty of evidence where students enthusiastically adopt them. But with these caveats, I mean, geology is an abductive science. It's characterized by, some elements almost unique to our discipline around deep time and expectation for low frequency, high impact events. But really, you can't meaningfully engage AI without mastering some of these sort of core skills that inform judgment. And understanding is a mental construct. It's what we make and do to make sense of distinct pieces of information. So whilst AI can store and retrieve information effectively, it can't comprehend meaning. So this is where this sort of combination of that previous diagram I showed could be beneficial. And of course, true understanding, involves many different aspects: judgment, reflection, and the creation of meaning, drawing on our experience, our values, our subject matter knowledge, and empathy, all human capacities that AI doesn't possess. And of course, also our intelligence and understanding is rooted in physical experiences, what we glean from field work and interactions with the world. And it's this embodied cognition that allows us to develop concepts that again resonate with our lived experience, which are absent in AI. So although we can summarize vast amounts of information and organize it, we can't build understanding. So students really need to build their own theories about what knowledge means for them. And I think that's key element of which you could go into a lot more sort of philosophy. And it's important not to exaggerate what AI is. A couple of things, going back to the sort of diagram, and going back to sort of the environmental element, is AI is this conscious choice and judgment about when to use it, and to be aware of the environmental impact. So, for example, perhaps students should be encouraged to write their own text first before turning to AI for feedback, rather than using AI to generate um, reports straight from a few prompts. Um, Also, perhaps using smaller models, privacy preserving models. Some universities are hosting their own language models for privacy rather than just relying on the ones that are in the public domain. And the other element is brainstorming. So right at the top there, there's some good research that in combination with AI, um, individuals and teams can potentially build more diverse sets of ideas. But at the same time, there's also research, if you introduce it too early, you start to anchor and bias people, which then leads to a reduction in idea diversity. So there's quite a rich and evolving set of social science research about, not only how to use AI, but when to use it, which will become, I think, increasingly important. So just before I go into some of the use cases, sort of in geoscience, I wanted to talk about really how do we just turn text to numbers. So a little bit of maths, the only slide I promise that's going to have it, but I think it's a very simple example that I've used over the years that could be beneficial. So we've got this sort of sentence in the southwest: the shore-faced green formation exhibited well-rounded textures with no fracturing. So what we can do is count the number of times words occur with other words. So in this case, we're going to do it for lithostratigraphic formations, such as the green formation. So if we had a question, which is what's a good analog for the green formation based on the patterns of words in text in this very simple fictitious example. So we've got there as rows 3 lithostratigraphic formations. We could have thousands or hundreds of thousands. And then on the columns, we've got 3 words, um, phrases. Again, we could have hundreds of thousands or millions of these to create a massive sort of sparse matrix. So shore face, for example, as a word, occurs 5 times around the green formation, not at all around the Beano, and 1 around the Nemo. So if we want to look at similarity, we can just take the cosine of these word vectors. So comparing the green and the Beano is just 5 times 0 plus 3 times 1 plus 2 times 2. Divide that by the square root of the green formation, 5 squared plus 3 squared plus 2 squared, times the square root of the Beano, 0 squared plus 1 squared plus 2 squared. We get cosine of 0.508. So the closer to 1, the more similar words are to each other. So if you had exactly the same words and exactly the same abundance, you'd have a cosine of 1. If we compare the green to the Nemo, you can see we have a cosine of 0.733. So we can infer from this very simple example, which is called distributional semantics, all dates back to the 1950s. From Firth, you can tell a word's meaning by the company it keeps, and also Harris, the distributional hypothesis, words that occur next to each other share some semantic meaning. These are the building blocks of the modern day language models that we use. We can infer that the Nemo formation is a better analog. And these techniques have been used in multinational oil companies and have been verified by geologists to identify new analogs that they hadn't thought of before, based on large amounts, in some cases millions of textual documents. They've also got some interesting properties. So in this example on the right, I'm just adding 2 word vectors together for hydrothermal and granite, and you can see the most common word vector is pegmatitic. So people have been surprised that these techniques have been around for quite a while, been surprised at some of the semantic information that's embedded within these word vectors, or dense vectors for the multidimensional area, or text embeddings. You might also hear them phrased as. So if we take this now into some examples and also more modern day techniques. So instead of sort of counting in that way, we can use artificial neural networks where each word starts as a random vector. And then as we feed training data sequences of text, we begin to learn the weights to predict the word associations. So you find that similar words that appear within the same words, same context, they begin to move closer together in vector space. So these neural models, they're computational efficient, nonlinear, compared to the linear algebra that you saw in the previous example, but they're both doing the same thing. They're both trying to model complex patterns of words in text, and in our case, text which is relevant to geoscience. And then right up to date with the transformer architecture, you have wider, much larger spans of words, being able to process rather than one word in sequence, but multiple words at the same time. We get parallelization, so we're able to use large amounts of text, which gives us some of the language models that we're using today. The example on the right is a text embedding model where I've taken from scratch 5,000 United States Geological Survey reports and created a text embedding model. And then I've looked at the cosine similarity of 7,000 minerals. So each of the colors there is a mineral grouped by class. So you can see the sulfides, silicates, etc. And then it's the dimensionality is being reduced using TS&E in this TS&E plot. So if I just look in this corner, you see some minerals, different colors, and it's molybdenite and scheelite, which are not particularly well-known associations, but because they're close together in the plot, they obviously share some implicit similar contexts, and that could have implications for porphyry skarn mineral systems. Now, you could say, or if you took a different set of documents, you'd probably end up with a different set of patterns, and you'd be largely true in that respect, as you would be in any machine learning exercise. However, what I've done is replicate the same association that Lawley found in 2022 using a completely different set of documents. So there are some underlying causal mechanisms which transcend different data sets, which could lead to scientific discovery and business opportunities. And in fact, they have. These techniques have been used in many other disciplines like material science to actually find new thermoelectric compounds. So again, not a generative use of language models, but a use for data discovery. We can, of course, also use for extraction. This is using a general purpose model, Anthropic's Claude. You can see I've just used a very simple prompt there for this mudlog image, where people have handwritten the descriptions. You can see there a bit messily over the logs, and I've just given it one example there in the prompt and asked it to extract out those cuttings by depth, and it does a pretty good job. Again, it's a general purpose model, not geology specific. Very good job. All algorithms, of course, need human oversight. But this will allow us to digitize information in archives that perhaps we wouldn't normally have done. Takes too long, and help us reduce uncertainty in our models and make some new connections. Again, another example. This is again using free-to-use Claude, Anthropic's Claude, and with just a few lines. Just took me a few minutes just to give you an idea of how long, with just some natural language statements about what I wanted, and this is using large language models to code for you. So I built a little app that allows me to load in a geological map, georeference it, and then select the lithology I want to extract as GeoJSON. So the green that you can see here, the mica-rich metamorphic rock, I've been able to pick that, select it, export it, and then on the right-hand side of the slide, you can see that where I'm displaying that geological formation in another application. So really just a glimpse of some of the possibilities that we can use these general purpose models for. This is an example taking extraction further. So I could have used a document, but I've just used a short amount of text just to illustrate the Lower Triassic Bunter Sandstone Formation is a major prospective reservoir for carbon capture, etc. So I'm using GPT-4 here, again, another general purpose model, not geology specific. And you see my question is extract the associations for lithostrat, chronostrat, and sentiment, etc. So I haven't used much prompting at all, very simple. It does a very good job of extracting that from text, again, without having to do any specific prompt engineering or machine learning. So imagine we did this paragraph after paragraph, sentence, document after document, thousands of documents. We can build up a knowledge graph of a large collection of our information where each circle here, each node is a concept. It could be a geological formation, it could be a process, could be a geographical area, a borehole. And then the lines are the fact an association has been found between those two concepts because they're in the same sentence or semantic unit. And then the thickness of the line is how often it's been found. So the useful thing with these sorts of techniques is not just the numbers, but so quite often we might have, say, porosity, permeability, or the rheological properties of a geological unit, but the fact that perhaps that unit has been karstified, the diagenetic thematic processes, the structuration, they're often left in documents. So we can also bring these out and again help us make into structured form new connections that we hadn't made previously, or just new data to reduce uncertainty in the models that we produce. They can also power visual summaries. So we often think of a summary of sort of a set of documents as being very textual, but by nature, the summary often smooths out the outliers. And of course, outliers in many cases is where we can learn the most. So what you're looking at here is a lens of petroleum systems on a large amount of documents for an area along the top there with the different petroleum system elements by geological age. So someone working in this area will have a mental model of what they're expecting to see. Um, they might look at this and say, okay, I can see there's some oil shows in the Miocene. I wasn't aware of that. That discrepancy, which is data driven, this is what the data's sort of telling you, would most likely lead that person to click out of curiosity to find out more, which could lead to a learning event the person wouldn't have had they not been stimulated with these summaries. And you can think of, instead of petroleum system elements along the top, it could be mineral systems, could be hydrogeology elements, and lots of examples where this has created new learning points from vast amounts of information that there's no way that anyone would be able to read it. So again, the visual summary is good way of coping with information overload. So this sort of human AI teaming concept, using it as a Socratic partner, we've seen examples where we can use it for coding, we can use it for extraction. Obviously, a lot of people use it for question and answering and for reviewing their own documentation. But it is important we disclose where we use GenAI, a key ethical principle of transparency, to allow informed consent. When people read information, they know the provenance and source of it. And really, we should be writing in our own voice. So to use these tools very much as an assistant for the work that we do. I just wanted to point out a property of models around scenario planning. So the top example there I took from a magazine recently, which is really posing a counterfactual question, which is what would be the implications if the reservoirs in the Tano Basin were also present in the Quetta Basin? And you can see in the prompting, I've started to elaborate a bit. And the third one from the bottom is simulate 5 multiple plausible outcomes. And what you find with language models, and everyone would have experienced that you come up with a slightly different answer um, each time you use it for a variety of reasons, or random nature of the generation, is that for some questions and answers, you can ask the question 100 times and you might well get the same answer more or less 99 times. So you very low entropy in the model. But for certain other questions, you'll have quite high variability. So there is a possibility to generate some variance in the response, which gives you an uncertainty, a confidence element of what the model is telling you. Not necessarily geological uncertainty, but uncertainty about the responses from the model that you may be applying in a geological context. And it really gives rise to this fact that prompting is not a technical trick. It's increasingly being really a foundational element of literacy for geoscience. Just in the same way that if you had two geoscientists that were given a research question and asked to gather information via Google, you would end up with, even if the two geoscientists very similar roles, using the same tool, they might well end up with completely different results in many cases. There's a lot more to seeking information than just knowing what buttons to press with technology. And if you think of the Google and the different range of things you can do for searching, when you use language models, that's really exponentially expanded. So I think that's a sort of a key element of literacy. And then the second example at the bottom is using Perplexity, where again you can generate reports which are, as an example of a RAG, a retrieval augmented generation implementation, which are referenced. So again, it can help you find some references that perhaps you may have otherwise missed through your work. And I think this analogy, I've used a food analogy here of, the geoscientist being the chef, we're in charge. The APIs to these external, internal data tools from in companies and institutions, these are the ingredients and the recipes, the servers and the MCP protocols, the supermarkets and suppliers, and then these large language model and large language model based applications, the smart sous chef. So they may give you advice, but you can also tell them to go away and cut the vegetables, and they'll do that in a very relatively autonomous fashion. So that's an analogy. I'm not sure if it's a good one of just trying to position how these large language models and AI work with geoscientists in our workflow. This is a tool that I released in August, open source. So all the software code is there, so people can take it and do what they wish. And it allows really is to try and stimulate experimentation of what's possible. And it allows you to make a query in natural language and then get data back from unstructured sources. So it will go and search the internet for you using DuckDuckGo in the background, a sort of more private search engine, gathering PDFs that match your query. It'll mine those PDFs for more search terms and then make more search queries that you didn't necessarily think of yourself. And it will download it all onto your desktop, help develop a knowledge graph, and then also search open geoscience databases like MindDat, where the language model can interpret the API, how to interact with these structured databases to get the results. So the bottom right-hand example of show copper, nickel, gold in Namibia, it's able to interpret how to make that query to the MindDat database to get the database back, to get the data back, and then display that with satellite imagery. And all the data you're seeing there comes from outside a language model. So we're using the language model as almost like a semantic layer between what we want and then all these external information resources. And that's quite a different use of a language model to getting answers from inside the model. And it's very important to think of those two divisions when you're talking around language models. There's a link in GitHub, and also had quite a bit of interest already from various geoscientists using it in different places. So going on to the ethical considerations, where we touched on some of them already. There are the 2021 ethical recommendations from UNESCO, which are quite high level, but very valid, signed up to by over 150 countries around, do no harm, things like data privacy, the sort of transparency elements. And then in 2024, the International Science Council released a framework a bit more focused on large language models and frontier AI, really a sort of set of questions to make you think when you're creating a model or a system, to make you sort of reflect really and ask yourself some questions. Some of them individual, some of them are about the environmental aspects around the social geopolitical constructs, as well as the data and the model. That's an interesting one to read. So what we did around a year ago, when the Geoethics Commission of IUGS set up an AI task group, is we looked to see where there were issues happening within the geosciences, despite those frameworks existing, and tried to produce a little bit more sort of specific recommendations. So we use those from UNESCO and ISC ones as sort of background. Sort of did a literature review, and also use sort of critical realism as a philosophical lens, which can be useful because it sort of forces us to look at hidden structures, power dynamics. When an AI system is created, who gains from this deployment, who loses agency, um, and really puts power inclusion and exclusion central to ethical evaluation. And then we also used a virtue ethics approach to morality, focused on developing good character. So rather than sort of blindly following rules or just aiming for the best outcomes, it asks, what would a good person do? Guided by our moral virtues like honesty, courage, and empathy, and intellectual virtues such as practical wisdom and intuition. So the core element is, what kind of person should I be? Or what should a good geoscientist do? And together we can use judgmental rationality, which means that we can rationally evaluate and compare competing knowledge claims or proposals. So um, it means we're not trapped in relativism. There are universal principles in AI ethics, and some outcomes, processes, theories can be judged better or worse than others. So the recommendations, and there's a 30-page report which is available for people to read. It really was about what does good look like for ethical AI. I mean, issues around AI ethics are only going to expand. We know that geosciences have unique characteristics that justify a dedicated approach rather than relying on some of those high-level ethics frameworks. The international nature of Earth observation, the intersection with national security, things like critical minerals, resource sovereignty, and then the direct connection to climate and environmental policy. So we have quite a distinct ethical landscape in our discipline. And of course, there have been and remain some repeated AI ethics failures in the geosciences. So, we have some work to do on that. And some people might say, well, we've always had ethical issues when we use technology in the geosciences, or even, the statistical machine learning. And it'd be true, but I think the frontier AI, these opaque large models, which now more and more people are using rather than specialists, um, allow reporting across massive data sets. They can easily be repurposed, and it makes them more scalable. So we can amplify those risks and also create some new ones. So you can see a range of examples in here. Recommendation to use RAG, to build systems with privacy by design, so people have to opt in for their data to be used for training rather than having to opt out. And also geopolitics. I mean, AI is a concentrator of power, so providing free AI is good because it gives that capability to people. But then if it's in exchange for their data, you can create ethical issues that may be, even more harmful around data sovereignty. So, there are some big factors to consider. And so far, we've also had organizations representing about 300 geoscientists endorse the report, which is sort of ongoing. So finishing off with the sort of literacy, what does it mean to be literate around AI in the sort of geosciences? And I think this foundation layer is this core knowledge skills still need to be taught. Of course, observational, analytical reasoning, being able to communicate, and having that core geological and geoscience knowledge, and then being proficient in how to use tools such as LLM prompting that we've seen, handling data, be understanding, and of course, depending on your role, different levels of depth you need here, but at least some understanding of the data science, so you understand, the limitations for some of these techniques and algorithms, and then critical thinking. The habits of a questioning mind, being able to critically appraise content, make judgments about whether you should use or trust that information, and then checking outputs as geoscientists move increasingly to overseeing AI algorithms, there are in some respects new tasks being created in the checking and validation of the work that's going on to support our processes. And of course, as we've just seen ethics, what would a good geoscientist do incorporating those moral, intellectual virtues, not just individual, but for society. Um, if you're producing a model, and I've seen many examples in journals now. I mean, AI used to be machine learning used to be just present in very narrow set of articles, but now you see it in a lot of journals. But you see information published and claims made where the model hasn't been released, the training data hasn't been released, the test data hasn't been released. So you can't reproduce or scrutinize the claims being made to the point that you may even go as far to say, is this science at all? So I think there are many questions that we need to look at in that area. So I think in summary, um, we need to experiment. I mean, these tools clearly have benefits. We need to be cautious, question, of course, how AI shapes knowledge, but steer a pragmatic course. We often hear the end members on social media or elsewhere of hyperbole, where people are using value-laden words to describe AI for various motivations. And then on the other end of the spectrum, people cherry-picking examples where things don't work, um, perhaps overt negativity, and maybe that's a reaction from the former. But somewhere in the middle, sort of a pragmatic approach, may help us realize some of the benefits of the techniques that have been released over the last few years to help us in our work and better serve society. That's all I have. Thank you very much for listening. Happy to take any questions.
Thank you, Paul, for such an insightful presentation. I'm very glad that you share all this with us. And yeah, let's start with some question. I'm checking on the chat box, but I don't see yet a question. But I have one because after you show this knowledge graph you created with all this information, so I have a curiosity from the educator perspective. How do you think? How do you recommend we can use the large language model in teaching? For example, would you recommend to educators, geoscience educators, create their own specific domain knowledge graph on the subject, or let's say geography or something? Or do you think it's more effective to use some knowledge graph already created for other researchers?
I think network graphs, and sort of knowledge graphs, is a very visual way to look at connections between things. And we're a very visual sort of discipline, with time and space being, the two big, sort of dimensions in geoscience. And we have our, stratigraphic column. Um, and so I think using visuals to represent ontologies, as well as hierarchies, where everything is, is a or part of, whereas you expand it to an ontology and the relationships become, things like deposited by or caused from. I think can help us make different connections, and they don't need to be generated from text. Of course, you can create them by smashing together different sort of structural data sets, um, and then visualizing them, including the outliers. I think is quite important. I mean, summarization fits a particular purpose, but sometimes we can lose those edges when we summarize. So being able to capture that in visual summaries in some way, I think is a helpful element. Not every outlier, of course, you're going to learn from. It could be just an artifact, but it could be a useful technique.
Yeah, yeah, because I saw some examples. I don't remember it was from China or US that some um, teachers in high school they like um, encourage the use of knowledge graph in some topics. Yeah, like you say, for because it's very illustrative for the student. So they are trying to use this for each subject. No, let's say
Mm.
environmental science, and it's I saw they are kind of experimenting, but not yet integrated totally. Because like yes, like you say, they need the geoschema or the ontology, and it's like they have to work on something that at the moment it doesn't exist. So that's why
I mean, there
I
there are
think
some
is
mm, there are
yeah.
some RDF sort of schemas in geology that you can use and ontologies. Um, and I think, I've been creative. When you think, what is it to be creative? It's sort of making connections between things, and I think that's where explicit conceptualizations like knowledge graphs can be, is quite helpful in a sort of visual, sort of way. Obviously, when you use a large amount of information, it becomes so dense that you can't really visualize it, but they can then be used to help. And there's quite a bit of work, trying to combine data-driven techniques, such as sort of language models with, um, more symbolic approaches of describing, theories and sort of connections. You can see how they could be combined with things like language models, so that we don't get, nonsensical answers, and give a bit of direction, from our theories. So, but I'd encourage people just to experiment. There are a lot of free knowledge tools out there. Um, Resource Description Framework, or RDF, is a sort of relatively standard. Um, and if you like learning by doing, then I think I would just get stuck in to some of these things. It depends on learning style. I think some people like to go through more formal courses. But from my own experience, I bought a lot of books on Python and creating knowledge graphs, and um, opened very few of them in the end, because it sometimes is better just to learn by doing. So it depends on your personal learning style. But I definitely encourage experimentation.
Yeah, that is also something linked to my second question, which is about which tools or skill set do you recommend for educators, and also for the students to that they have to prioritize to work effectively with a large language model or other AI tools.
I wouldn't necessarily say one. I mean, I think I don't know if it's a good analogy, but I'll use another one. It's like reading newspaper. I mean, I don't think it's ever a good idea just to read the same newspaper. So it's good to read a few, and then you form a sort of a holistic view of something. Just the same way we read academic papers. So if we're using language models, I think you use a few of them, and you might use the same prompt with the same information. You might get slightly different answers, or slightly different opinions. And if we're using it, as an opinion, which we can take or leave, or take bits of it, you use a few. There are quite a few that are free. Um, um, and yeah, just should be careful what you upload into these models. So it depends on your use case. But I also look at trying some of these smaller models. You might be pleasantly surprised by, depending on what you're doing and how good they are. that you might be able to run on your own machines as well.
Yeah, so they also have to learn programming, right? Because
I,
if we don't have this, yeah, yeah, I had also the experience of wanting to use AI tools, so I had to learn from scratch Python and
I,
R.
mm.
I also check Julia, so it is very important
I think it's
as
helpful
a
to
recommendation.
learn.
It's,
Yeah, it is
mhm.
helpful to learn things like Python, but um, I think some people, just like some people are more musical than others, shall we say? I'm not musical at all. Some people just don't get programming. They just don't think that way. The same way that I would. I've tried and I can't, play the piano. So um, I don't think you need to be a programmer to actually experiment with AI. I mean, there are lots. So you saw that little app that I created. I didn't code anything. I just wrote what I wanted, and it built the app for me. I'm not saying it's production quality, but in terms of prototyping things, experimenting, and there are so many different ways that you can look at how these techniques can benefit your work tasks that don't involve programming. So I think, if you're that way inclined and you want to learn programming, yeah, absolutely. But I wouldn't want the message to be that, okay, I'm not a programmer, I've tried it, I just don't think that way. This whole area is not for me. Because I think that would be the wrong message to take away. I think there are many no-code solutions to using some of these techniques and actually being innovative and creative without writing a single line of code. So I think there are many different, ways that people can interact.
Okay. And Giuseppe, you have a question.
Yes, I have a question. Sorry, I didn't find how to unmute the microphone. So thank you, Paul and Sandra, for organizing this. I want to ask you to Paul whether you think that the evolution of these technologies is numbing human analytical skills and in a certain sense stifling young people's ability to be creative and intuitive. So, in other words, we should be careful to introduce this technology into education.
Oh, yeah, it's a it's a very good question, Giuseppe, and I think the cognitive offloading, is different. I mean, we've always done cognitive offloading. I mean, the Mesopotamians with the clay tablets. I mean, that's a form of offloading. Then the Google, the exobrain, not needing to remember certain things because we can just go and look it up. But of course, with language models, we're moving up that Bloom's taxonomy. We're not now just using these tools to remember things, but also to sort of summarize and recommend things. So, crudely, you might say slightly higher order sort of elements. I think this is where the sort of educating people around the appropriate use of some of these things, because people are using them outside maybe institutions anyway. Um, and so I think there is perhaps a responsibility from institutions to ensure people use them appropriately, rather than just ignoring or hoping it will go away. I mean, I think people are using them, so we can perhaps teach the most ethical and responsible ways to use these techniques, and they can be beneficial. And that brainstorming one would be an example. It's not just to blindly rely on the large language model to come up with ideas for you, but actually use it. Once you've come up with some ideas and done some work, as then another form of opinion. So it's how people use these tools. I mean, always has been, really, and there will be people that will use it well and people that won't use it so well. So I think that's maybe where the education comes into things. People have different approaches. I mean, I think I've read in some cases banning the use of sort of all AI and for coding. And then on the other side, people moving to more oral assessment where you have to explain your work much more orally to show that you can understand, what's happening. But yeah, it's getting to grips with some of these new technologies. But I mean, we've always moved things when we moved from hand contouring maps to gridding and GIS systems. People raise some of the same questions. So I think it's just an evolution, another technological evolution, albeit perhaps with some um, some new elements we haven't seen before.
Thank you. Thank you.
Do you think there is another ethical consideration? So when we are going to introduce AI tools in geoscience education, Paul?
Well, I think there's some of the techniques I showed is not generative. They're some around data discovery and extraction, and I would say even if we didn't evolve language models any further than where they are today, in many respects we haven't taken advantage of some of the techniques that have been around for 5, maybe even 10 years. So I think there's a non-generative sense that we're perhaps not using language models as or not getting the benefits as much perhaps we could. Obviously, on the generative side, we don't want people just to create some AI slop and just cut and paste it into their essays and things like that. So on the generative side, yes, there are some there are concerns, and there will be many issues around how that's being abused. But it's out there, and I don't think sticking our head in the sand is the best approach. I think we need to tackle it and provide as much education as we can.
Yeah, I guess it's a lot of misunderstanding and misconception about the use, and for sure this is going to continue being challenging. But yeah, I see this in a positive way. No, like you say, now we know that we don't need a specific programming skill. We can experiment, or we can use some uh, tools that are online, and let's try to continue learning. Thank you, Paul, for such insightful and engaging session. And thank you all for being here. And on behalf of the Commission of Geoscience Education of the IUGS and our Subcommission on Education, Outreach and Policy, we are very grateful for your participation today, and we hope this discussion opens the room and inspire continued reflection on this topic, because we are just starting. So before closing, I just want to let you know that we are organizing more webinars like this one. So I have copied the link for our website and the chat box, so you can check and engage with our content, following also our social media channels. Thank you, Paul, again. And do you have any words for closing the session?
Just say thank you for inviting me, Sandra, and thanks everyone for attending. And yeah, I think if we can steer between the hype and the negativity with a bit more of a pragmatic approach, then hopefully everybody will benefit.
Thank you again, Paul. Thank you, everyone, and I hope you have enjoyed the session, and have a wonderful weekend, everyone. Bye.
Bye bye.